Working live. Okay, so today is 11/19/18, right? So let's take a look at what we have. Sequence. Let's define what a sequence is. And I'm going to use English. I'm not going to use math words. All a sequence is just simply a list of numbers in order. Okay, it's just a list of numbers in order. That's all it is. For example, 2, 4, 6, 8, 10. That's a sequence. Just a group of numbers in order, right? 1, 4, 9, 16, 25, 36, 49.
They don't have to relate at all.
No, they do have to relate. Those are all the perfect squares, right? It's 1 squared, 2 squared, 3 squared, 4. So they have to have some kind of order, and the order is how they relate, okay?
So
we could go 1, 2, 4, 8, 16, 32, 64. I'm just doubling my numbers, right? So it's a list of numbers that has some kind of order to it, okay? So the terms of the sequence are those numbers, okay? So if we have a list of numbers, like let's say we just make it really easy. Let's go 2, 4, 8, 16, 32, okay? The terms are the individual numbers. So we'd say A1, that's my first number. A is just a symbol for your terms. A1 is 2, isn't it? Yeah. A2, that's my second term. It's 4. You've seen this before, haven't you?
I had a really hard time.
A3 is just my third term. In this case, it's 8, and so forth and so on. So when you see this symbol A, it's asking what term are you looking for. A1 is the first term. A2 is just the second term of any particular sequence, okay? Now, if I change this problem to 2 plus 4 plus 8 plus 16 plus 32, that's a series. So the difference is the series is just to add them all up. So a series is just the sum of the list of numbers. So the difference is you can get an answer. With a series, you can get a single answer because you can add them all up and get an answer. With a sequence, you're just listing numbers, right? One after the other. But in a series, you can actually get it. Now, there is a funny little symbol, and it's this Greek letter sigma. Okay? And I will never write it this good again. This is about as good as I can write it, and from here on out it'll be pretty sloppy. But that's the Greek letter sigma. So sigma notation, when you see this symbol, it is saying the following. When you see this symbol, it's saying add up all the terms. Okay? When you see the symbol, sigma notation, summation notation, it means add up all the terms. So we see the symbol, we know we're going to create some numbers, and then we're going to add them all up. Yeah, Ben?
So sigma of our list 1 would be 2 plus 4 plus 8 plus 16 plus 32.
Yes. It's just saying add them all up. Yes. Now we're going to put a formula in here, and the formula will help us make the sequence, okay? Or the series. Okay, let's turn the page. So far, so good? Turn the page. It's not hard, right? Okay, so let's take a look at, first of all, finite series. Now, this one's really easy. Finite series just means there's a countable number. It has an end. There's a finite number. So a finite means you will stop. It won't go dot, dot, dot. There's a countable number of terms. Okay? So in this case, there's 1, 2, 3, 4 terms. 4 terms. It doesn't go to infinity. There's just 4 terms, done, no more. It's finite. Infinite, you see the dot, 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 dot. There's not a countable numbers because it goes to infinity. Oh, sure. Thank you. So if it goes dot, 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 it goes to infinity, and therefore it's an infinite series. In this case, there wouldn't be a sum. There wouldn't be a sum to this. 2 plus 4 plus 6 plus 8 plus dot, 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 dot. It would go to infinity, and our sum would be infinity. Okay, so that's infinite. So far, so good? Okay. Here is a finite series. Okay. 2 plus 4 plus 6 plus 8. All right. And then they rewrote it in a symbol. So this 2 plus 4 plus 6 plus 8 can be generated by this formula. Okay, now let's look at this. And yep, Ben.
Question.
Mhm.
Like I always ask, how would this be relevant?
Great. Real quickly, Ben, let's say we walked into a warehouse and they had a whole bunch of PVC piping stacked up, a ton. And we just noticed that, you and I noticed that every stack was 2 less than the prior stack, up and up and up until we had a huge pyramid, right? And we said, okay, Ben, count them all. Or we'd say, wait a minute, I could use a formula to find out how many are there much faster than counting them all. Okay, that's just one very simple example. Okay, there are many more beautiful examples out there. Okay, all right, let's keep going on. So Ben back here. Okay, check it out. This symbol, you guys looking here? No, I want to go this symbol here. If I ignore the first part, it says a question. It says, you ready? I want you to watch this. It says plug in 1, plug in 2, plug in 3, plug in 4. So we start with 1. Let's plug in 1. Let's plug in 2. Let's plug in 3. And we'll stop at 4. Then we'll add them all up. So if I plug in 1, I get 2. If I plug in the next number, if I plug in 2, I get 4. If I plug in 3, I get 6. If I plug in 4, I get 8. And then if I plug in, nope, that's it. Just 1 through 4. And then if I add them up, I get 2 plus 4 is 6. 12 plus 8 is 20. So this is an actual question. This question says, add up all the terms. We have to make the terms first. This question says, add up all the terms. You have to make the terms first. So we start with 1, we plug in 1, we plug in 2, we plug in 3, we plug in 4. We make all of our terms and we add them all up. Okay? How am I doing so far? All right, let's scoot the page, all right? These formulas we're going to come back to later, okay? We're going to come back to those formulas later, okay? Not today. All right, scooting over. Am I going too fast?
No.
Okay, so example 1. Write the first 6 terms of the sequence. All right, I can do that. So I'm going to plug in. N is always these numbers. Always, always. 1, 2, 3, 4, dot, 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 dot. Dot, dot, dot just means how many you want to plug in. We want, in this case, to plug in 6. In our example, we're going to let n be 1, 2, 3, 4, 5, 6. Done. Does that make sense? I want to make the first 6, so I'm going to plug in 1, I'm going to plug in 2, I'm going to plug in 3, I'm going to plug in 4, plug in 5, plug in 6. I'm going to create a sequence. So let's plug in 1. So A1 is the first term. So to make A1, I plug in 1. I'm just going to go A1 is 1 cubed minus 1. So I'm going to plug 1 in for n. So that's easy. 1 cubed is 1 minus 1 is 0. So the first term is 0. A2 is made by plugging
Is that
2 in.
A3? No, that's 1.
Right. So let's plug in 2 into my formula. So I'll go A2, which is the second term, is 2 cubed minus 1. So I plug 2 in for n. 2 cubed is 8 minus 1 is 7. A3, my third term. Let's make my third term. A3, we'll just plug 3 into my formula in for n. So I'll go, okay, I can go 3 cubed minus 1, 27 minus 1 is 26. You see how easy this is? We need 6 terms. So let's make A4. We're going to plug in 4. Okay, I'm going to go 4 cubed minus 1. 4 cubed is 64 minus 1 is 63. Let's make A5. So plug in 5. 5 cubed minus 1. 125 minus 1 is 124. A6 is 6 cubed minus 1 because I plugged in 1, I plugged in 2, I plugged in 3, plugged in 4, plugged in 5, plugged in 6 because I need 6 terms. 216 minus 1 is 215. So my sequence is 0, 7, 27, 63, 124, 215. That is the first 6 terms of this sequence. And how did I make the sequence? I plugged 1, 2, 3, 4, 5, 6 into the formula for n. Thumbs up? It's not that hard, is it? It's not bad. Okay? All right. Now, if we're going to make a pattern, okay? If If we're going to make a sequence, then we need to have a formula, okay? So it says make a pattern, describe a pattern. So we need, our number 3 is backwards. We need to make the formula that makes this sequence, okay? We need to make the formula. So we need an A of n equals. Well, what do you notice about these numbers? Do you notice anything? What do you notice about it? If I'm looking at number 3, do you notice any pattern? What do you see? You guys see Nikolai, do you see a pattern? What's going on
I
here?
see 1s and 3s.
It's going up.
Oh, they're going up
Okay.
too.
Yes. So if I said 2n, that'll help me go up by 2's. But if I plug in 1, now watch. If I plug in 1, I won't get negative 3. So I make an adjustment. If I plug in 1, I'd get 2. But what if I go minus 5? Now, I think this formula is going to work, but let's try it. I think this formula is going to work, so let's try it real quick. Let's do it. So if I plug in 1, right? Plug in 1. 2 times 1 is 4 minus 5. Oh, that did not make negative 3. There it is. Oh, thank you.
Oh my god.
Okay, so I get, plug in 1, I get 2. That works. I got distracted. So I plug in 1. 1 times 2 is 2. Minus 3, minus 5 makes negative 3, okay? Let's plug in 2. 2 times 2 is 4. 4 minus 5 is negative 1. Good. Let's plug in 3. 2 times 3 is 6 minus 5 is 1. Good, I made the right formula, didn't I? I did make.
How did you guess that?
Well, I'm going to teach you. If it goes up by the same amount each time, it's multiples. That's all addition is. It's multiples of that number. That's why I went 2n, okay? And I'll keep talking about that, okay? So then write the next term. Well, the next term of this one's got to be 5. You guys agree? And then 7. That's easy, okay? Okay, let's look at 4. All right? So what do I notice about 4? Do I notice anything about 4?
They're all going up by 2/5.
They are. So if I make a formula, so the next one's going to be 10 fifths, 12 fifths, so forth and so on, right? So if I make a formula, 5 is always on the bottom, right? So if I make a formula, A of n equals 5 is always on the bottom, correct?
Right.
Okay. But then what goes on top? You said we're going up by 2's, right? So, in fact, I heard somebody say 2n. Well, if you're not sure, test it. Test it, okay? So plug in 1. Test it. Plug in 1. 2 times 1 is 2, or 5 is 2 fifths. Plug in 2. 4 fifths. Plug in 3.
6/5.
Plug in 4.
Wow, Mr. You
This-
did it again.
I did again. I'm pretty
You're
good.
actually amazing.
I'm pretty good at these. Now, 5. Summation notation, huh? So on 5, summate, guys, Ben, Nikolai, I'm going to start right here. Okay? Summation notation. I'm going to do that right off the bat. Got to write that symbol. Now that symbol means we got to add them all up, right? But I need a formula. So what's going on in this one? 1, 4, 9, 16, 25. What about these numbers? These numbers look kind of special to you?
They're square roots.
They're square numbers, right?
Yeah.
They're n squared numbers, aren't they?
Mm-hmm.
Okay, n squared numbers, right? But they go positive, negative, positive, negative, positive, negative, right?
Right.
Right? So I need to have, this one's a little tricky, but if I do a negative 1 to the n power.
Steve, you really screwed me there. I did not leave enough room.
Okay. Well, then put it on the back side, okay? Just put
Not
it back
your
there.
fault.
Well, okay, Ben, you can put it on the back side, okay? You want to put it on the back side, doesn't really matter. How is this going to work? Well, let's see. If I plug in 1, negative 1 to the 1 is negative, isn't it? If I plug in 2, negative 1 squared is positive. If I plug in 3, a negative times a negative times negative is a negative. If I plug in 4, 4 negatives is a positive. I plug in 5, right? 5 negatives makes a negative. And then I get 1 squared, 2 squared, 3 squared. Now, n has to start at 1. But where does it end? Dot, 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 dot. Where does it end? What's my last term?
It doesn't end.
So whatever number goes up here has to be my last term.
Freaking
How many terms are there? Yes.
infinite.
So we put infinity here because of the dot, dot, dot. I think that makes sense.
Alright, that was a horrible infinity.
Okay, number 6.
Good.
We're doing okay. Number 6. And number 6 is a little tricky, but we're smart. You ready? Watch my hands. Seriously, watch my hands. We're going to plug in 2, 3, 4, 5. How many terms are there?
4.
Okay, I'll do it again. We're going to plug in 2, we're going to plug in 3, we're going to 4, plug in 5. How many terms are there?
Oh, Mr. Baby, I don't like
5.
that.
So I'm going to have 4 terms. We're going to have my first term, A1, is made by plugging in 2. A2 is made by plugging in 3.
That's the best.
A3, I know, that's why I'm going slowly on this. A3 is made by plugging in 4, and A5. A4 is made by plugging in 5. So I'm going to start with 2. I'm going to plug in 2. Then I'm going to plug in 3. Then I'm going to plug in 4. Then I'm going to plug in 5. So I'm going to plug in 2. 2 over 2 minus 1. Then I'm going to plug in 3. I'm going to 3 over 3 minus 1. Then I'm going to plug in 4. I'm going to go 4 over 4 minus 1. Then I'm going to plug in 5 and go 5 over 5 minus 1. Okay, it's easier if we just ignore the, okay? So you notice what I did, Makaiwa? I ignored that, right? And I plugged in 2, I plugged in 3, plugged in 4, plugged in 5. So I wouldn't confuse myself, right? I do know that's my first term, my second term, my third term, fourth term. See how easy I could do it if I just... So it does make sense. So this is going to be 2 over 1, which is 2, right? 3 over 2, which is 3 halves. 4 over 3, which is 4 thirds. 5 over 4, which is 5 fourths. But I'm not done. You know why I'm not done? I have to add them all up. How do I know I have to add them all up?
Because it's the sigma.
It's my sigma. So I'm going to get my calculator, and I'm just going to let my calculator do the work for me. 2 plus 3 halves plus 4 thirds plus 5 fourths, and I get an answer of about 6.08. How's that? Okay, I'm almost done. Turn the page. Nope, don't turn the page. I think I'm done. How's that?
That's awesome.
Was that not too bad?
Do we have homework?
Yes.
Because I really